I'm going to start a couple of minutes early. That way, if there's any questions, I can tackle them before we hand out to you, Rahul. Thanks. So this is just going to be a little brief presentation, kind of talking about why we have this really nice convergence today between the Node.js platform and this concept of microservices, which is sort of another name for SOA, but with a different spin on it, and containers. The explosion of containers and Docker in the world, and the ability to think a little bit about your architecture and take advantage of a very nice stack. So we've come a long way, I guess, from the way we built web applications in the past few years. This three-layer monolithic stack kind of represents the traditional way of looking at our web application architecture. The presentation layer, the business layer, the data access layer, talking to some relational database, and ultimately provide rendering pages that would be displayed in a browser. And why this model has worked, and actually it has some advantages, but it also has some ramifications. And some of those ramifications include it's not optimal for a continuous deployment environment. Updating a single piece of a big monolithic application is not something that you do lightly. So generally, you're going to devote some time to a process that verifies that the application is safe to deploy. All the moving parts are going to be ready to run in some environment, and that's time consuming and risky. Also, in terms of scalability, while it's a simple model for scalability, you stick it behind a load balancer and just have multiple web applications running behind that load balancer, it's not optimal in the sense that you can't take individual pieces of that application that need to scale and scale those in a more cost-effective way. Also, you can't necessarily scale that single connection to the database easily, and I'll talk about that in a little more detail in a moment. And then finally, there's an impact on your developer scalability. When you have a large code base, the cognitive overhead is higher. You've got to partition things up into teams where people have different responsibilities. There's more communication involved in kind of coordinating the updates to your code base. There's more to understand. It's a higher learning curve for the new developers. It's just a little more challenging the bigger the code base gets, and we all know that. And finally, it may not sound like a big deal. Usually at the beginning of a project, it's not a big deal, but for a very large application, you're making a long-term commitment to a technology stack. So, you can't necessarily take advantage of some of the things that come down the road that might make it a little bit nicer. Hey, I want this service or this message queue or this component runs on a different stack, but it doesn't fit into the stack that our team has been using that's part of this big, large web app. But today, we kind of have a different world. APIs APIs rule, right? APIs are used for a lot of reasons. And it's not just websites that are consuming APIs, although, yeah, APIs actually deliver a lot of the functionality that websites are using to present data, but it's your web apps that are running in your browser and your desktop clients as well as your mobile devices, whether it's a web app or a smartphone app or tablet app. And of course, the growing world of the Internet of Things, all your connected devices. These are consuming APIs, and APIs are out there talking to other services exposing APIs. So modern apps are API consumers, and an application really, it's not the monolithic web application. Your application is just the set of APIs that you need to consume that are just right for your target device. Maybe a different subset of APIs, but it's a collection of APIs that present a particular experience that's device appropriate. So, you know, APIs. Yeah, I don't know. If you don't, I saw the Kim Kardashian cover, and I had to steal it. But anyway, actually, it's funny, but no, really, it's actually not even really about APIs. It's really about services. You know, services are just communicating processes over a network. Okay, provide some functionality to some consumer. We're talking about today in this environment, you know, services that communicate over a lightweight protocol, basically for the modern web. So, okay, so that sounds good. We're talking about services, and instead of a monolithic application architecture, hey, maybe our app is going to talk to some API, and that API is going to leverage some of the APIs being provided by some other services, like in this hypothetical store application that's now, you know, instead of being one big monolithic application, is 5 communicating services. And that sounds great until you start thinking about, you know, hey, nothing changed, right? Our inventory service is huge, 20,000 lines of code. Boy, we need a domain model. We need we need to have dependency injection for all our vendor adapters and stuff like that. And no, you know, that's actually not the idea. The idea is that we'd like to be able to build our applications from orchestration of a bunch of lightweight, narrowly focused, granular services, and each service having the ability to evolve and to be deployed and to scale in a production environment independently of other ones. We want to be able to partition these services along functional boundaries, not technical boundaries like that application stack that we looked at, that 3-layer technology stack. So enter microservices, and that's just kind of a new name, arguably just a new name for service-oriented architecture, which has been around for a long time, and that's true. But it's kind of carries a little bit of a nuance with it. It's a little bit more narrowly focused in meaning today. The emphasis is on lightweight, literally lightweight in terms of lines of code, and the other aspects to building and deploying these services. So lightweight, less ceremony, easier deployment, fits well into continuous integration environments, stuff like that, based on REST, not based on this huge body of web service standards, WS standards, running over HTTP, and doesn't require an enterprise service bus, stuff like that. Anybody that's worked on, you know, enterprise service-oriented architecture environments will understand the difference. To quote Adrian Cockcroft from Netflix, it's a fine-grained SOA, and so that's what we mean when we say microservices. So what are the disadvantages? Because everything comes at a price, right? There's no free lunch. When you start talking about microservice environments and lots of microservices, you do have a more complicated system in a different dimension. You're now talking about a distributed architecture, and distributed architecture does bring its own complexity into the equation. With all of these services now, yes, they may be more loosely coupled, they may be more tightly focused. Single teams can own a complete service and be responsible for the entire, you know, development and deployment of that particular service, but that involves its own complexity, both in terms of management, the operational complexity, you know, dealing with monitoring, diagnostics in a production environment, dealing now with the fact that you've got, instead of everything inside of one big process, you've got a lot of communication going on now across process. You've got to bring network considerations into that equation, you know, latency, timeouts, that kind of stuff. So there are disadvantages. And this is a chart that comes from the URLs down here at the bottom, but there was a book called The Art of Scalability, and this was presented in that book. When we looked at that monolithic architecture in the beginning, we were talking about x-axis scaling, which is to be able to scale, you got to make copies of your web application, and that's scaling along the x-axis here. Now, there's a way to optimize that a bit. I kind of mentioned like the database scalability, because no matter how many web apps you've got, if they're all talking to a single database, you're not really scaling your database, so that's your potential bottleneck. With z-axis scaling, what you do is you've got some kind of intelligent router that's dividing up your requests for data along some partition. You're going to shard your data in some way that allows requests coming in for certain types of data to hit one database, requests for another type of data hit another database. So you've taken your overall database and divided up, sharded it so that requests can be routed by these different web applications, which are just copies of each other. But that brings in a lot of complexity also. You've got to very carefully consider how you're going to shard your data, and that's a big management headache. So that leaves us this y-axis, and the y-axis scaling is along functional decomposition. Exactly what we were talking about with microservices. The idea is that you're not scaling your monolithic application. You've broken it up functionally into communicating processes. Okay, and so you've got now a number of services to divide up the work, and that's the y-axis. This is a scale cube model. You'll hear about it when you hear conversations about microservices. So that brings us to this meetup in Node and why we're here. There may be a lot of reasons why you're interested in Node, but Node is a particularly good and strong fit for this microservice pattern. Okay, over the years, if you looked at different solutions people have come up with for building component-based architecture, back from Corba or essentially the various ways that people could try and break up problems with object-oriented programming and components, but some kind of mechanism. Node actually brings this really realistic way of breaking things up very efficiently. It's got a great package management system that encourages you to build small packages that are narrow in focus, and it makes it easy to consume packages that you need through a registry. And there's a global public registry, and you can host private registries for packages you need to keep internal to your organization. But this package management system actually delivers on this promise of kind of component-based programming. Everything about the platform encourages you to build these small, and if you go and visit the registry, you'll see that the vast majority of packages that are out there are very single purpose. They address and solve a narrow range of problems, and that's a really cool approach. It's easy to take ownership and build and maintain and evolve these narrowly focused packages, which map very well to our idea of microservices. Node was designed from the beginning to be an end-to-end solution for building high-performance server applications. It was built from the top down to deal with asynchronous I/O. It wasn't an add-on to the platform. It was designed from the beginning. The default names of functions actually have many corollaries where it makes it explicit that you're calling a synchronous version of the function. You generally, for your web applications, your web services, you want to take advantage of that asynchronous I/O. Excellent performance on the platform. This is a dynamically typed language based on JavaScript, and yet thanks to the investment in technology that Google made, the V8 engine that powers Chrome, we actually have a platform that runs on the server side that takes advantage of V8 and actually delivers pretty incredible performance. In the world of services where latency dominates, V8 allows you to deliver services that are going to run and perform extremely well, and about as well as some of the solutions you could build based on a competing technology. So, and then I guess the benefit that JavaScript actually fits really well in the middle, since JavaScript does power most of the clients out there, at least the browser-based clients, and it maps very well to your document-oriented NoSQL database solutions out there that were designed to be very scalable. So this entire stack for the web, backed by these very scalable data solutions on the back end, they all map very well to expressing data over your HTTP transport as JSON. Having JavaScript in the middle just makes it that much easier to build your services. That doesn't mean that everything you do has to be in JavaScript. Node allows you to build APIs that can map very well to legacy services and legacy databases in your organization that you might end up using Node just to build a wrapper over, an API veneer. But it's a very good fit. It's very low overhead in building a Node app, very light on ceremony, especially if you're used to building Java Enterprise apps or .NET apps. If you haven't been exposed to it yet, you will get exposure in here. And I'm running out of time, so I need to step this up. NPM, the package manager for JavaScript, its growth has been explosive, and as of now, it is actually the largest package management system in the world. That title was once held by CPAN for Perl, but it's a growth, especially when you look at the fact that it started so much more recently in time. It's been stratospheric. At this point, yeah, we are. And when I did this, actually, this was a few weeks ago. I haven't even checked the number today, but it's, we're well over 100,000 packages at this point. I'm not going to do a demo. We'll save it for next time. Microservices sound great. Node sounds great. It sure would be able to take advantage of this, and furthermore, be able to make it really easy to provision lightweight environments to host our microservices. And that's there are a couple of platform as a service providers that do make it easy. We'll talk about them over the next few months. I'm not going to go into the benefits right now because I am running out of time. I will briefly highlight on containers. Containers, for those of you that haven't yet heard about Docker, for example, technology for building and running isolated operating environments, for being able to run your software in this isolated operating environment. If you're not familiar with it, an analogy might be a virtual machine, but whereas a virtual machine abstracts your hardware and presents kind of a little mini, this is the operating system that's got to get installed, and all the packages and everything so that your software can run. A container is much more lightweight. It runs on top of a kernel that's running on top of hardware. Individual containers will share that kernel. So really the abstraction level is only at the operating system level above the kernel. So you can run many more containers than you could virtual machines. They can also be started much faster. They're very lightweight. Disadvantage is you're sharing the kernel, which means you got to one isn't Windows and one is Linux and or CentOS and one's Ubuntu. They all need to be. You need to share that same Linux kernel, but other than that, you can get, for example, if I can get 4 virtual machines on a server, I can get 16 containers running just as well. And I can start them up a lot faster, and I can manage them with very easily with a single little manifest file called a Dockerfile, and we'll cover that in future sessions. They're portable, they're lightweight. The concept is you can take these containers and actually ship them and run them in different environments. So you might actually build your containers to run in the Azure cloud and later on decide you're going to run them on Amazon or on Google. Not a brand new technology. Actually, Google leverages containers, huge number, 2 billion per week. They actually may not be 100% accurate on the exact origin, but I believe the early days were from Sun. But Google's been a big part of this for a long time. They some of their engineers are the ones that added the enhancements to the Linux kernel to enhance this isolation between processes running in these restricted groups on the Linux kernel. And I'm going fast. This is what a Dockerfile looks like for standing up a, in this example, it's actually running Node on CentOS in a container. Pretty simple. We'll cover that in a future session. Okay, so this all sounds good, man. So now we talked about microservices and Node, and now we're looking at containers, and containers sound really cool, but if I'm working with containers, what's that going to look like? I mean, once I've built my app and, it's working for me, but I'm going to get this out in production, and how does that work? How do I deploy? How do I update? How do I deal with scaling? And if I'm scaling, how do I deal with discovery? If I bring up multiple containers in a cluster, how do they announce that they're ready? How do I orchestrate communication among these services that I've deployed to these containers? What about resource management? How do I restrict CPU, memory, storage, that kind of stuff? How do I monitor my services in a container? And how do I deal with failed services? So those are all good questions, and I'm out of time, and these are questions that we're going to be addressing over the next few months. We're going to expose you to the Node ecosystem, get people up and running with Node and comfortable with Node, and then continue on that arc and actually talk about how you build some really cool services and deploy them and monitor them in real-world scenarios. So that's it. I'll take like 30 seconds of questions, and then I need to turn over to Rahul for his talk.